Example number 1. So find the length of the graph of f of x equals x cubed over 12 plus 1 over x, and this is for x between 1 and 4. And so we're asked to find the length of the graph, or the length of the curve, and we're going to use our arc length formula to figure that out. So let me show you a picture of the graph real quick, just so you can see what it looks like, and then we'll do our computations to figure out the arc length. So here's a picture of our graph. We are focused on the arc length from x is 1 until x is 4, so I have those points labeled. I'm going to use just a straight line to show you how the straight line would approximate the distance, and I am going to just use one straight line. And so our actual arc length of our curve should be longer than this. So let's see if we can get that to show up. So distance here from there. Okay, so it's about 5.4, and that would be for a straight line from this point A to B. Let me see if I can draw that line for you really quick so you know what I'm talking about. And then our actual arc length is going to be longer because our curve is longer than this straight line that we just drew. So let's get that. There we go. So when we do our calculations, we should expect a number a little bigger than 5.4. Okay, now using our formula for arc length, notice what you need. You need the derivative of your function, and then after you find it, you need to square it and then add 1, and eventually square root. So you do need to start with the derivative. So find f prime of x first. That's a good starting point because we need that as part of our integrand. So for this function, straightforward derivative, f prime of x, we're just going to use the power rule, 3x squared over 12. And then this is technically right here, let's rewrite it, x to the negative 1, this term. Let's make it a little bit more clear. Okay, so this is negative 1 times x to the negative 2. And then we'll make this look a little bit better. The 3 and the 12 can simplify. This is x squared over 4 minus 1 over x to the positive 2. Okay, so that is our derivative. Now, the next thing we need to recognize is when we plug this into our formula here, it just inside this integrand, we're going to have to square it and then add 1. Now, I'll show you the whole thing right now, and then we'll stop and just work on algebra and then come back and integrate. But technically at this point, our length that we're looking for is the length from x equals 1 to 4 on our curve. The integrand is going to be 1 plus our derivative squared, x squared, our square root of 1 plus our derivative squared. X squared over 4 minus 1 over x squared dx. Okay, so this is what we're ultimately trying to find. But I'm going to work on the algebra for now and then come back and integrate it once we have this integrand simplified, because right now it's pretty ugly. So we're going to focus on just the integrand, specifically starting with what we have to square. So when we FOIL this out, if it helps you, go ahead and write this as the same quantity times itself. If that's going to help you make sure you get the right expansion for this binomial. Okay, so we have x to the 4th over 16 minus, so on this next term, the x squareds are going to divide out, so minus 1/4. This term here, the x squareds are going to divide out also, so minus 1/4. And then plus 1 over x to the 4th. Okay, that's actually, let me clarify this, that's only this part, so I still need to add the plus 1 in just a minute. So let's just keep working on what this looks like. This is x to the 4th over 16 minus 1/2 if you combine these two fractions, plus x to the 4th. Okay, and now I do have a plus 1 over here in the front. So this is kind of ugly still. Notice it's still going to be in a square root, and I still have to integrate it. So it's not in a nice form for me to even think about integration just yet. I need to keep doing algebra to make this look better. Let's go ahead and combine the 1 with the negative 1/2. So we get x to the 4th over 16 plus 1/2, 1 take away 1/2, plus 1 over x to the 4th. Now you might be able to recognize this, how this is going to factor out. It's actually going to factor very closely to what this already looked like before we FOILed. But I'm going to walk you through it, so just in case you're like, I have no clue how to work from here to move forward, this does factor, okay? So I have a kind of a math tool trick for you for how you can make this easier to factor if you don't see how can I factor at this point. Math tool, multiply by the number 1. So this is a polynomial that's not the best to factor based on how it looks, just because intuitively we might not recognize how to factor this. So the number 1 that would help us here is to make this polynomial not have fractions. So what we want to do is we want to multiply by the number 1 in the form of, let's go ahead and move this real quick, 16x to the 4th over itself. And here's why that's a good option. It's a good option because if we multiply by this, it will get rid of all of the denominators in all 3 of our fractions, and we can see more clearly how we can factor that out. So when I'm going to leave the denominator out here. So we're going to leave that right here, and then we're going to distribute this numerator in order to get rid of these fractions. So this is going to become, so watch as we do it, or maybe you can beat me to this if you try it on your own. The 16 is going to divide out here, and we get x to the 8th. Then, next term, the 2 is going to divide with the 16, and we're going to get 8x to the 4th. And the last term, the x to the 4th is going to divide out, and we're going to get 16. Okay? And so there's still this fraction we introduced with the 1 over 16x to the 4th in the front. But that's going to let us factor this more easily. That one hopefully you can see by looking or maybe trial and error how to factor it. And so this factors, if you realize what you're going to need for the first term is x to the 8th. So if we have an x to the 4th times itself, we do need a 16 at the end here. So let's see if this is a nice factoring. 4 times 4 is 16. If these are both positive, this is 4x to the 4th, and then this is the other 4x to the 4th. So this does represent this polynomial factor. And then let's bring this fraction out front back down. 1 over 16x to the 4th times x to the 4th plus 4 quantity squared. Okay, that was to make our integration easier because we're going to have to take a square root of this. I left out the square root through this whole process, but remember where this came from. This was inside the square root. And so going back to our integrand now, taking it right from here, we have that the length that we're looking for is the integral from 1 to 4 of the square root of, let me go ahead and combine these. I'm just going to write it as one giant fraction, x to the 4th plus 4 squared over 16x to the 4th dx. Okay. And now because we got this to factor so nicely as a quantity squared, we can go ahead and take this square root, and this becomes so much better than what we were dealing with before and as far as integrating goes. So this becomes the integral from 1 to 4. Square root both the top and bottom. You can go ahead and take the square root of this whole quantity. On top, that's x to the 4th plus 4. On bottom, that's going to be 4x squared when you take the square root of the denominator, dx. And this is so much better than how we began, and we can integrate this no problem if we go ahead and just separate this fraction here. So let's write this as 2 terms, x to the 4th over 4x squared plus 4 over 4x squared dx. And then we'll simplify a little bit, and then you can use your power rule to finish this off. So let's simplify, and I'll leave my formula right there for the next example, but let's see what we get. So coming in from right over here where we left off, integral 1 to 4, this term, the x squared on bottom divides out, so this is x squared on top over 4. And in the second term, the 4's divide out, so this is 1 over x squared dx. Power rule works here, so this is x to the 3rd over 4 times 3. Over here, this is x to the negative 2, so this becomes x to the negative 1. This is x to the negative 2. So when I add 1, x to the negative 1 over negative 1. And we'll evaluate from 1 to 4. Then make this look a tiny bit nicer. X cubed over 12 minus 1 over x, evaluated from 1 to 4. And I think this actually looked really close to what our original function looked like. I did erase it, but let me look back at my notes. Yeah, so our original function, this is just a coincidence, but it looks very much like our original function other than this was a plus sign. So I'll let you plug in these numbers, plug in 4, and then subtract when you plug in 1. And then when you do this, let's see what you end up with. You will get final answer of 6 units. All right.